Welcome back. This is fourth lecture of class 11th chemistry chapter 3 periodic table. In this lecture we shall discuss periodic trends in physical properties. First of all, let's understand that what are periodic trends. So there are many observable patterns in the physical and chemical properties of elements as we descend in a group or move across a period in periodic table. So if you have ever observed a periodic table, then in that table you can observe that if you move from left to right in a period, then you will observe some patterns in the properties of elements. Similarly, when you will go down in a group, you will also observe some similarity in the properties. You will observe some pattern in the properties. These patterns are called periodic trends. For example, we have discussed in the last lecture that metallic character decreases as we move from left to right in a periodic table. So group 1 elements have very high metallic character, but as we move from left to right in the table, the group 18 elements have very low metallic character and they are mostly non-metals. So in this way you can see that there are many observable patterns and these patterns are called periodic trends. So these periodic trends can be observed in both the physical properties as well as chemical properties of elements. But in this lecture we shall only be discussing physical properties. The periodic trends in chemical properties will be discussed in the next lecture. So let's start with today's topic, and that is periodic trends in physical properties. Now in this we shall discuss 4 periodic trends. Atomic radius, second ionization enthalpy, third electron gain enthalpy, and fourth electronegativity. So let's understand each one of them with various examples. First, atomic radius. So in the previous chapter, that is structure of atom, we have discussed that determination of atomic size of an atom cannot be precise. So in quantum mechanical model, we came to know that we cannot determine the exact atomic size of an atom. We can only say the probability. So this means that the exact atomic radius cannot be determined. But the average distance of the valence shell electrons from the nucleus is called atomic radius. So as the exact distance cannot be measured, that's why we take the average distance of the valence shell electrons from nucleus as the atomic radius. Now let's see that what is the trend of atomic radius in periodic table. So in a period, the atomic radius decreases as we move from left to right in a period. Now let's understand this with the help of an example. So let's take the example of few period 2 elements. So you can see that the first period 2 element is lithium, then we have beryllium, then boron, then carbon, then nitrogen, and then oxygen. After that also there are few elements which we shall not be mentioning them. So we know that the atomic radius of lithium is 152, beryllium 111, boron 88, carbon 77, nitrogen 74, and so on. So you can see that the general trend is that atomic radius is reducing as we move from left to right. As we move from lithium to oxygen, the atomic radius is reducing. Now let's see the reason that why this trend takes place. So we know that when we move from left to right in periodic table in a period, then atomic number increases. So atomic number of lithium is 3, beryllium 4, boron 5, carbon 6, and so on. So atomic number is increasing as we move from left to right. Now as the atomic number increases, more number of electrons have to be present in the same valence shell. So as atomic number represents number of electrons, increase in atomic number means increase in number of electrons in that same valence shell. Now this results in increased attraction of electrons to the nucleus. So as the attraction of electrons to the nucleus increases, the atomic radius decreases, because we know that atomic radius is nothing but the distance of valence electrons from the nucleus. So due to more amount of attraction between the nucleus and electrons, they will have to come closer, so atomic radius will reduce. So this is the explanation that why atomic radius decreases as we move from left to right in a period. Now let's discuss that what is the trend of atomic radius in a group. So as we descend in a group, atomic radius increases. So let's understand with the help of example. Let's take the example of group 1 elements. They are lithium, sodium, potassium, rubidium and so on. So here I have given you the atomic radius of all these elements. You can see that the atomic radius is increasing as we are descending in that group, as we are moving from top to bottom. Now what is the reason for this? The reason is that as we move downwards in a group, the number of shells in elements increases. So in the previous lecture, we learned that the period indicates the number of shells in that element. So as we will move from one period to the next, the number of shells will increase by 1. In the first period, the element will have 1 shell. In the second period, all the elements will be having 2 shells. In third period, all the elements will be having 3 shells, and so on. It will keep on increasing. Now as the number of shells is increasing, this means that valence electrons get farther from the nucleus, because valence electrons are those electrons which are present in the outermost shell. So obviously when the number of shells will increase, the distance between valence shells and nucleus will have to increase.
Now, as the distance between the nucleus and valence electrons increases, that's why the atomic radius also increases. Now, the second physical property of the elements in periodic table is ionization enthalpy. The tendency of an element to lose electron is called ionization enthalpy. It represents the energy required to remove an electron from an isolated atom in its ground state. As the electrons that are negative charge are removed, the ionization enthalpies becomes always positive. So you know that electrons are negatively charged, and whenever negative charge will be removed from an atom, always it will become positively charged. So that's why ionization enthalpies are always positive. Now let's see the trend of ionization enthalpy in periods. So ionization enthalpy generally increases as we move from left to right in a period. What is the reason for this? So as the atomic radius decreases, the valence electrons get closer to the nucleus. So as we move from left to right in periodic table in a period, the atomic radius will decrease, and due to this, the valence electrons get closer to the nucleus. So the attractive force between nucleus and electrons increases. So more energy is required to remove the valence electrons. Thus, ionization enthalpy increases. Now, there are few exceptions. For example, ionization enthalpy of boron is slightly less than that of beryllium. So in this table, you can see that though all the other ionization enthalpies are increasing as we move from left to right in a period, but ionization enthalpy of boron is less than that of beryllium. This is an exception to this law. Similarly, ionization enthalpy of oxygen is slightly lesser than nitrogen. So these exceptions are also very important and you must remember them. Now let's discuss ionization enthalpy in groups. So ionization enthalpy generally decreases as we descend in a group. Now this is because, as I have discussed before, ionization enthalpy is inversely proportional to atomic radius. So as atomic radius increases down a group, ionization enthalpy decreases as we descend in a group. Now let's discuss the third property, that is electron gain enthalpy. So, tendency of an element to gain an electron is called electron gain enthalpy. So, ionization enthalpy is tendency to lose electron and electron gain enthalpy is tendency to gain the electron. And electron gain enthalpy is generally negative. The element which will gain electron more easily will have more negative electron gain enthalpy. Electron gain enthalpy generally becomes more negative as we move from left to right in a period. And similarly, electron gain enthalpy becomes less negative as we descend in a group. So on moving from in a period, it becomes more negative, and it also becomes less negative as we descend in a group. So these were the properties and trends of electron gain enthalpy. Now let's discuss the fourth and last property, that is electronegativity. So the ability of an atom in a chemical compound to attract a shared pair of electrons is called electronegativity. So in a chemical compound, as you know that there is sharing of electrons. So during that sharing of electrons, the ability of the atom to attract the shared pair of electron to its side is called electronegativity. Electronegativity generally increases across a period from left to right and decreases down a group. Now this is because electronegativity depends upon atomic radius. It increases with decrease in atomic radius. So this was all for today. In the next lecture, we shall discuss chemical properties of elements in periodic table. Thank you.